Okay, so I have like 5 tips here to prove or verify identities. So my step 1 is not very mathematically elegant, but I'm going to say work on the ugly side first. The worse the side looks, probably the more you can do with it. So I always say work on the ugly side first. And then my next step is to use trig identities after you decide which side to work on. And then look for algebraic operations such as like adding fractions, distribution, or factoring to help you simplify. So adding fractions, distribution, and factoring. Last thing that you can do, I'm not opposed to doing this first, but you can change the sines and cosines. And then the last thing is do not, how do I want to phrase this? Do not go across the equal sign. Okay? Stay on the side you are on. Okay. All that being said, let's do these next 2 questions here on this page. So prove cosecant squared x minus 1 over cosecant squared x minus cosecant of x is equal to 1 plus sine of x. Okay, like I said, ugly side first. That means there's probably more you can do with it. So I'm going to draw my line. All right, we could change things to sines and cosines. Sure, but that really wouldn't do a whole lot for us here. What I do see, we could use a trig identity with cosecant. We could use 1 plus cotangent squared of x is equal to cosecant squared of x. That would work. We could say cosecant squared of x minus 1 is cotangent squared of x. 100% totally okay. I don't know. I just don't know if that's going to be kind of useful. You could try it, see if it works, but I have a better idea. I'm going to look at my algebraic operations, and I am going to factor. Okay, so the top part of this fraction is a difference of 2 squares, cosecant squared and 1. I can factor out this top and make it look like cosecant of x plus 1 cosecant of x minus 1. Okay, difference of 2 squares on the top. And on the bottom, each of these terms has a cosecant of x in it. So I'm going to factor one of them out. So difference of 2 squares on the top, cosecant squared of x minus 1. Now remember, difference of 2 squares, that's like if I have something like x squared minus 9, and that became x plus 3, x minus 3. That's how you factor that. Similar thing on top, just with cosecant squareds. And then on the bottom, I just factored out that cosecant. I get cosecant of x times cosecant of x minus 1. Now, very quickly, we can see that like something glorious has happened here. We have 2 terms that are identical on the top and the bottom. They get to go away. So I am left with cosecant of x plus 1 on the top over cosecant of x. Now, if you have 2 things being added or subtracted on the top of the fraction, you can break that fraction up. So I can break this up and say cosecant of x over cosecant of x plus 1 over cosecant of x. We usually do this step in reverse to get this step. So, but you can break a fraction apart into common denominators, into 2 fractions with common denominators. So these 2 things are equivalent. And then cosecant of x over cosecant of x is 1. And then 1 plus cosecant of x is sine of x. And that matches our original function. All right, so that one's like a little, we'll kind of get into it a little bit. Try that one on your own. See if you can do the same thing or same process. See if you can kind of see how it goes. Or see if you can take it a different way. I think this is the fastest way to do it, but you may find another way that you like that makes more sense for you. So give it a shot. Now, the second one on this page, 1 plus cosine of x is equal to sine squared over 1 minus cosine of x. Ugly side first. I'm going to work with the right side here. Now, if I look at my left side, and this is part of like kind of like how do I know what to do? What do I know what steps to take? If you look at your left side, you only have a 1 and a cosine. So for me, if I have a sine squared or something along those lines, if I have a term on my one side that I don't have in my answer, like I want to find an equation that takes care of that. So we know the big one. We know sine squared of x plus cosine squared of x is equal to 1. That means, and we've maneuvered this equation around already, that sine squared of x is equal to 1 minus cosine squared of x. Okay, so I'm going to rewrite sine squared as 1 minus cosine squared. All right, now we can't cancel anything out right now, right? Think of these terms as just like stuck together, can't break them apart, do not cancel anything here. Okay, no. But what I can see is that this top is again a difference of 2 squares. Okay, it kind of is of this form, 4 minus x squared. And we would say that this is 2 minus x, 2 plus x. It doesn't matter which one's plus or minus. But this idea I can apply to 1 minus cosine squared. So I'm going to say 1 minus cosine of x, 1 plus cosine of x, all over 1 minus cosine of x. Okay? If you've done this right, something should cancel out, and we have the same term on the top and the bottom. They get to go away, and I'm left with just a 1 plus cosine of x on both sides. I cannot emphasize this enough. Do not cancel out anything in this first real step, okay? These terms are put together. If you need to put little parentheses around them, you cannot break these things apart at all, ever, under any circumstances. You can factor and then cancel things out, but you cannot break up. Like, you can't divide out the ones. You can't just divide out a cosine. It doesn't work like that. So just, I cannot emphasize that stronger. Please, please, please don't do that, because otherwise disastrous things are going to happen, and it's not good. But that's how you would do these two. If you find another way to do it, great. But once again, I like to show you the fastest way and kind of, I feel like, the more intuitive way. But if there's another way that you think makes sense to you, go for it, try it, and see if it works. If you're having a hard time with that way, give this way a shot, all right? See if it works out for you.